Function notation. Let's consider the relation y equals 5x. Now this is a relation because there's a relationship between y and 5x, so they relate to each other. But this is also a function because if I draw this graph, it's going to be a straight line, which means I only vertical line test only intercepts the graph once, which means for every x value, there's only one y value. So this is a function. Now, if you can remember correctly, we say that y depends on x, so y is the dependent and x is independent. So if I want to find the value of y, I have to do something with x. I have to perform a function. So if x has got a function, so we can say y is a function of x. So when I want to find y, I pick a value for x and I do a function with this, and therefore I get a y value. So we can say that y is a function of x. And this is how we abbreviate it. Now just for future references, sometimes they use something like gx or hx. It's the same thing, it's just if there's more than one function, we don't want to call it fx1 and fx2 and fx3. We just say fx, gx, hx. It means the same thing. It's a function of x. So often we can replace y with fx. So if our rule is y equals 5x, I can then also evaluate this function, which means I can say, what is y if x is 1? And all I have to do is then replace, wherever I have an x, 1, I'm going to use brackets because sometimes this is a complex function, and 5 times 1 is 5. Which means if x is 1, y is 5. Let's see what is the function if x is 3. All we do is substitute, so it's going to be 5. Wherever you see an x, wherever you had an x, you're going to have a 3. And 5 times 3 is 15. So when x is 3, y is 15, or the function is 15.